switched.
How often do you shave?
Awful.
I would shave every day.
Okay,
Every night.
so
I don't.
let's look at
I shave every
more separable variables today,
summer.
and then we're going to look at a specific equation that's pretty important in a lot of applications tomorrow. Okay, so we'll split it in 2 days. So 6.3 is kind of just like more separable variables, a little bit deeper into that. Separable, yeah. Okay. And what we'll do tomorrow is the logistic equation.
Yeah.
I think we may, I don't remember what I did with you guys last year. I think we may have actually looked at the logistic equation. I was planning on it, I don't remember. We'll see. Okay, so today, more separable examples. Let's see.
Teachers, at this time, would you please release all of the volleyball players to the lunchroom? Thank you.
Don't do it, Riley.
I have to. She's my best friend.
Go ahead, Riley.
What about me?
I'm sorry.
You'll be taped, you'll be fine.
The
Start
guy
with those.
played here.
Wait, what? That was tangent of x. No, cotangent.
Okay, so we wanted to use the same strategy we did before, nothing different. Somebody tell me what to do with the first one.
I would.
You move the x's over one side and the y's over the other.
Do you multiply by 1 over dy?
Divide by what? Oh.
Divide by y and divide by x
Divide by
squared
y.
plus 4.
Oh.
And then put everything else over there. So we're going to have x divided by x squared plus 4 and multiply the dx up. And notice, when you do that, you're kind of like setting up an integral, right? So this should look kind of like an integral when you do it, hopefully. At least on the ones that you're doing in this class, because they're cooked up to be not crazy, unexpected things you can't do, you know. So now I do what?
Solve.
Take the natural logarithm.
Integrate,
Integrate.
which becomes, Brett,
The natural logarithm.
of,
The absolute value of y.
And
okay,
then that side, you have to pull out a 4, and then x over 2
it's
squared.
a natural log of
Oh.
x squared plus 4.
Oh.
That x messes up.
Oh yeah, the
tree
x
stuff.
does mess it up, huh?
the x does mess up, otherwise if that x wasn't there, if that was a 1,
I don't understand why we got the half.
then it will be an arctangent.
Actually, no, 'cause
And we'd have to modify it, but since that x is up there, the derivative's almost sitting right on top.
So you made it.
This is a 2x, Austin, then you wouldn't have to have the 1/2 there,
Oh,
it'd just be
okay.
1 over u, right?
So you used u.
But, yeah. Good point though, I like that we brought that up. That's almost an arc function, it's all about that x. If it wasn't up there, then it would be arctangent something, yeah. And then we absorb our c from this side and this side and call it c temporary. And then we do what?
Take the e.
It, so this one's not super fascinating. We've done it before.
1/2.
So we get e to the 1/2 natural log of x squared plus 4. Since that's always going to be positive anyway, do I need to use these absolute value bars really?
No.
You really don't, right? And with logarithms, what can you always do with coefficients that are down in front if you wanted to?
Put 'em up
You can
there.
make them up.
You can put them up there. If you have an exponent of 1/2, what's that become?
The square root.
Ah, so this really could become natural log of the square root of x squared plus 4, right? That'd be the nice way to write it. And then it's e to that,
Plus c, so then it's
so e to the c out, e to the ct out in front becomes,
So is that
C.
CT up top or no?
Yes.
Like, okay.
yes, it's up top, good question. So then I did e to
Yeah.
the ct is this c, right?
C.
And then e to the natural log, look, it's right there.
So those
Ah,
cancel out.
those would
So
cancel
then
out.
it's just root, so it's C root that.
Yes, that was unexpected, yeah? So it's c root that.
No,
Can you see why you really kind of needed to move this 1/2 power up on this one? Because otherwise you were thinking the solution was a natural logarithm, but was it? No, it wasn't a logarithm at all. Turned out to be a square root function with a scale in front of it, okay? So sometimes unexpected things happen. I think that in differential equations, You need a lot of experience. That's why you take lots of classes in them if you're going to do something with them.
With the 1/2 in front of the logarithm, there's a property that made it go to the exponent spot. And that's
Yeah.
With logarithms, remember, if you have the log base anything, base b of x, and you put some number in front of it or some variable, whatever you want to
You
put
can
here,
just raise it to the end.
you can say that's log base b of x to the c power.
okay.
Because
You
didn't
can pull this down, or you can put it back up. We need to put it back up in this one.
Nice.
Okay? All right, this one, next one.
It's the
That was
same.
cool, I liked that. That was like judo. Okay,
Judo calculus.
judo calculus. What should I do?
Divide by sine x.
Yeah. Or how should I rewrite this? We don't want Newtonian notation.
dy over dx.
Yeah, that's gonna help us more. So
Newtonian.
cosine x over sine x. That's tangent x, right? You probably want to think of it like that.
I thought I was thinking of it.
Move this up,
Sorry.
put that there.
You'd want to
Maybe
leave it as
cotangent.
cosine over sine because you have an easier time integrating.
But
it.
isn't tangent?
That's
fine
true,
over cosine?
but
It is
tangent's one of those
cotangent,
ones
too.
we should memorize.
But that's also
Tangent's-
cotangent,
yeah.
not tangent.
Tangent's-
Okay,
Oh,
okay, it is
oh,
cotangent.
oh, oh, oh,
Okay.
Oh, yeah.
I was like, isn't that cotangent?
Austin's like,
I
oh
did-
my
I was
life, I'm
afraid.
getting confused.
Thank you. Then integrate, right?
Mhm.
What's over here? Easy.
Why?
Y? Yeah, we didn't have to do anything this time. What's the
Natural
integral
log
of
sine,
cotangent?
Natural log of sine.
You should at least remember tangents, and then you can guess. Tangent is negative
So it's
natural
ln
log.
of cosine.
So it's not.
Tangent is negative natural log of
cosine.
cosine, so this one is positive natural log
of
of
sine.
sine plus, let's just call it c instead of c10 because we don't need to move anything. So. Okay, let's see what else we've got. Maybe we'll just do 2 more today.
And then now.
If that's what you need, yes. Okay, those were both general or particular solutions we found?
General.
General, okay. Alright, so this time I want to find an equation curve that passes through a specific place, 1, 3, and has a slope of y over x squared. We had these kind of problems at the beginning of the course. Do you remember this? Sometimes they gave us a derivative and said, find the tangent line. This is really similar to that. It's really similar to that. So it's the way that they phrase it makes it slightly different. But basically, if the slope is supposed to be that, well, how do you say slope in calculus?
dy
dx
dx equals.
Yeah, rise over run in calculus is dy dx.
Y over.
Make the slope that. Yes, it turned out to be a differential equation. So this is a condition that the only way you can write it, express it, is what? A differential equation. This is a differential equation condition, whether or not you realize that it is. Okay? So if we find the general solution, we'll accomplish that. And then this is going to give us the
Z.
particular curve that you've got in your slope field. Okay? So now I just do what I do. I don't think this one's hard. This one's basic. I'm probably going to want to write that a different way, right? Once I integrate, how should I rewrite that?
X to the negative 2.
Yeah.
So we're gonna have y.
This one becomes natural log of y. That one becomes negative 1 over x plus a c temp. Be it.
So it equals c e to the negative 1 over x.
Y equals c e to the negative 1 over x. Yes. Now that's only the general solution. So if we had our slope field going,
Now you substitute
we'd have
solve
a
our
bunch
C.
of curves that would look like that. We need the one that passes through this point. Can you guys see how this is really close to those problems at the beginning of the year where they said, make a tangent line that passes through this point? It's really similar. Okay,
3 times e.
so
What would it be?
it's not.
3 divided by e to the negative 1.
e to the what?
Negative 1.
Negative 1.
Well, that's 1.
Yeah, one
Equals
over
3.
3 here.
So then 3 divided by e?
3 times.
What's e to the negative 1?
That's a
One
good
over
question.
e.
I'm putting it in my
It's 1 over
calculator.
e, right?
So times
No, you don't need that, right? Look,
3 times e.
that's 1 over e. So that goes here, you multiply that up here, and look, c is just 3 e's. I prefer to have that than the decimal. So that when you plug that back in, up here you get your particular solution, which nails down your path in the river, right? So now you get, the particular solution is 3e e to the negative 1 over x. Can we clean that up? That looks, ugh.
Equals.
Can you square it? Like negative 1 over x squared.
What's the
Is it
exponent?
3e to the negative 1x plus 1?
Listen to Caitlin. She's saying
Why-
you can put a what here?
Why did we get 2 e's?
So, you know.
I thought you just put 3 in for.
So it's
You add.
negative 1 over x plus 1.
What?
Austin, yeah.
Why don't you just put in 3 for c right there and leave it as y equals 3e to the negative 1 over x?
But because c has to have another e in it
Oh,
from over here.
sorry.
Okay. So it looks weird when you got those 2 e's there, so this is a much better form of the
So
answer.
you're just like plugging, like 3 e's, the c, so you're just plugging.
Yeah. So you came in, Riley, we were just doing one. They kind of phrased it a little bit differently, but it was basically the same thing. We first found the general solution, then we plugged this point that it was supposed to pass through in the slope field. It's just the initial condition.
Okay.
We're just doing more practice of what we did before. A little bit harder. That one wasn't any harder. I like this little part right here. Such an important rule, that exponent rule. I'm telling you, the better you are with the chain rule, the better you are with that exponent rule. That makes or breaks you in like all kinds of math classes. Because it keeps coming up in different ways, and it's just like, do you see it now? It's the same concept. Let's do one more. I think we're good. We'll do the logistic stuff tomorrow. How about this?
I can totally see. I see these here, not a snowboarder.
I do too. Loser.
I like skiing more. I hate snowboarding.
So
Why are they talking about skiing versus snowboarding?
because Todd is going skiing this weekend.
Hey, skiing's the best.
Hey, me too. Todd, let's go together.
That's creepy.
What if Chelsea got
Right.
I don't want to go do that.
Let's put an initial condition on that. I want a particular solution.
Wonderful.
I'd say. Oh.
Okay.
Could you start?
And you move the dx over.
I feel like if you just
Separating, what do I do?
It's a mess.
Y squared minus 1 over y dy equals
well,
Caitlin's saying, oh, she's already.
negative x
Okay.
dx over e to the negative x squared.
And you can talk like
Move this over here. I think that's what we all had as an idea. And then Caitlin divided through the y. Move this over here.
And then move the e to the
And move that thing over there with division.
which is
So you get y squared minus 1 divided by y dy. We okay with that?
yep, I got that part.
Equals negative x.
e to the x squared.
That is down here, right? Since that's a negative exponent, what can you do with it to help yourself? Just move it up at the top and make it positive since it was underneath. And we've already got a dx there. Do we count for everything?
Yeah.
Check if you've got a lot of pieces. Integrate. I think we're ready.
My cancerous neck.
Separate on that one over there.
Yeah, let's do the right side first. That's easier this time. What's going on over in the ER?
I
They
don't
go
know.
crazy.
Having
I don't know if I
rave?
want to know. I'm thinking of a particular Family Guy incident.
Oh god. I don't even want to know.
You don't?
Yeah, no.
Okay, so this one. Is this going to be easy to
Yeah.
integrate?
It's the product rule.
U is
Or
what?
not the
Don't you just
U is e to the x squared.
U is
X squared.
X squared.
X squared
One
du
half.
is 2 x dx.
Mhm.
We've got an x dx right there. I just thought I'd write it out in case you guys wanted it. Pay attention.
Yes.
Hey, you too. Okay, so we got a minus, pull it out, put your 1/2
Negative
out there.
1/2.
And we've got e to the x squared, right? Plus a c temp.
So then the other side, are you gonna split them up?
Yeah, so let's just write it off to the side over here. So y squared over y is what?
Y.
And 1 over is 1 over, right?
So it's gonna be ln of y.
So that becomes, that part is, the first
Y
part's
squared
what?
over
Square
2.
root 2 minus natural log.
Minus natural log of y. We move that constant over and absorb it over there. Now, what do you guys think? Are we going to be able to come up with an explicit solution to this equation? Or it just says y equals? This is an implicit general solution. I don't think so. I don't see how you could possibly like factor this out and somehow get y by itself. It's like I was locked in the logarithm. I don't know how that could happen. Sometimes you just can't get an explicit solution. You have to leave it implicit. So could you put this in your calculator to check?
No.
No.
Darn. Could you put it in Grapher on your computer to check?
Yes.
Yeah. You can put this in
How would you
Grapher.
do that?
We can look at it maybe. But when we get to some AP problems that are,
No, I mean like in the graph, what would you be looking for?
what do you mean?
Like you said, you could put it in. Like I know where
Or
to.
your phone.
Just your computer, if you just erase and you go to the graphing
Uh-huh.
functions, it'll let you just start typing. You can just like type that straight in,
And it'll give you the answer.
and it'll show you what it looks like. Our calculator, it has to be in explicit form
But
before
you
you
still
can
have
do
to
it.
solve for the initial condition.
I do still need that, right? Because how would you put this in a computer? It doesn't know what that is. It has no idea. You need to put that in first. Good. So we need to put this in there and come up with a particular solution.
So on the left side, that'll be pretty easy.
0 minus
Yeah.
1.
So when y is 1.
So I'm just gonna put 1 in for the y's, so we get 1/2,
Oh,
right?
yeah.
Minus the natural log of, what's the natural log of 1? That goes to 0, right? Think of the picture of the graph, the natural logarithm.
Got it.
Yeah.
Negative 1/2.
Equals 1/2, negative 1/2, e to the 0.
Squared, so just 1/2.
equals
So just negative 1/2, because that's 1. So we've got 1/2 over here, 1/2 there.
So you
Add
get
that. Oh my
1
gosh,
equals 2.
that's good, because now we can just put. Okay? But you couldn't put that in your calculator, unfortunately. You have to use software.
How come the
They should
calculator's
make a
not-
smarter calculator.
It's just a require. I don't know. I think nowadays they could probably get that in a calculator.
Do you think the TI Inspire does it?
This, yeah, the Inspire would do that, yeah.
I think they just.
That'd be
tell
one of
kids
the
to
things it
start
can
using
do. The
calculators.
problem is that Inspire takes so long to learn. Like I would have had you guys get it, but it's just, it does a lot more things than these, but it takes so long to learn that it's just not worth it in my opinion. So these can do almost all the calculus stuff you
So
need.
Connor has to get a new one, so I told him that he can take mine and I'll get the new one, just because I like new things.
It'd be fun. It'd be good just to try to
What are
learn
you gonna
some
do
of it.
more
So.
than that?